Hi, and welcome to this GCSE chemistry clip. This one is going to look at polymers and the bonding that occurs within polymers, typically within addition polymers we'll look at in this clip. So this module may sit within two specific areas. You may see it belong within the organic chemistry section, but primarily the bonding we're going to look at here is actually contained within section 2, so it's more of a paper 1 type situation really, so be aware of it in either of the papers if you're on an AQA syllabus. So what we're looking at, as we say, is an addition polymerization area here. So we're going to take a molecule of ethene, we're going to take a number of these, and we are going to polymerize them in a way in which we have seen before if you look into the organic chemistry clip section on the channel. And so we would get these bondings created here, whereby a polymer is many repeated units carried on theoretically indefinitely. And so you would get ethene creating a polyethene molecule. And when we represent these diagrammatically, you may see them simply represented as a long chain molecule. So we get this is literally a long chain molecule. The key area there being that it is still a molecule. And so it is made up of covalent bonds along the chain. So as we've drawn this diagram here, in the horizontal direction here, we have covalent bonds, which are typically very strong. So that would give us strong bonding along the chain. Because this is a three-dimensional solid, we're going to have many of these chains side by side within our solid structure. And so what we're now creating is a force in the other direction. This is being between one molecule and another molecule. So between the top and the middle molecule, and likewise between the middle and the bottom molecule. And we know that molecular forces, or as we're looking at here, intermolecular forces of attraction. So we know that these intermolecular forces of attraction, so forces between molecules, are relatively weak compared to covalent forces, to covalent bonds and to ionic forces. But because we have long chains and because we have large molecules, the size of that force goes up. So the size of the force increases based on the size of the molecule. So very large molecules have very large levels of intermolecular forces, which gives rise to polymers typically being solids at room temperature. But polymers are slightly different in the sense that what we can do, they have different physical properties. And if we heat up a polymer, so if we heat up a plastic, so for the students who are studying DT, for example, you will know things such as thermosoftening plastics. This being something which you can heat up and you can mold into a different shape. What you're doing there is you're weakening the intermolecular forces between the individual chains, between one chain and another chain. That allows you to reshape the structure into the shape you want. Then as that substance cools, those forces can grab hold of each other, can grab hold of each chain again, and reform the solid. And it maintains the solid shape that you've shaped it into. In a thermosoftening polymer, because we've then just recreated an intermolecular force in a different position, you can heat it up again. That becomes a repeatable process. And so you can shape your plastic into any number of shapes that you want repeatedly. That would be a thermosoftening plastic. You may have heard of something called a thermosetting plastic. There may be other terminology around. But for a thermosetting plastic, once you've heated it, something within a chain, for now we'll just call them magic groups, but at some point during the heating process, you shape your plastic into its new shape. And what happens is you create a link between one chain and another chain. This time, what we've done is we've managed to get one chain upon the process of heating, and whilst you're reshaping it, it's been grabbing hold of another chain, but this time has actually introduced a covalent bond. This therefore massively increases the forces of attraction, or more correctly, introduces a covalent bond on top of the intermolecular force of attraction that existed between the chains. And so once you've heated and shaped a thermosetting plastic, these magic groups have created covalent bonds, which means that you can't subsequently remelt it. If you were to try and heat up a thermosetted plastic, typically it would start to char. It may even set on fire in a direct fashion. It just wouldn't melt in the typical way you would expect it to do. These types of plastic will be used for plastic kettles and things like that. You shape it once, and obviously once you're boiling the water, you don't want it to reshape and soften. Otherwise, the kettle's going to lose its solid shape and it's going to become a mess. So you want your plastics to maintain their rigid structure. You would introduce these groups. Now, typically within certain chemical situations, these could be sulfur atoms, to give them precise examples rather than just calling them magic groups throughout, but these could create things like disulfide bridges that would be present in certain rubber manufacturing, where tyres you introduce sulfide bridges. Biology would use disulfide bridges between their molecules, but for what we need, we can simply say that what we've done is we've created a cross-link between one chain and another chain. But what we have to do is, when we're talking about our basic polymer, without these, we have to be very careful to understand that within each chain, the singular chain, we have strong covalent bonds, carbon to carbon bond typically along the chain. But between the chains, between chain 1 and 2 and 2 and 3, we have intermolecular forces of attraction. These are relatively large because of the size of the molecules that we're looking at. We've got large molecules giving us larger intermolecular forces, leading us to have solids at room temperature. But what we have to do is, as we keep stressing here, it has to be the intermolecular force that we're weakening. We are not breaking the covalent bonds within the chain. They stay intact, and we just weaken the intermolecular ones. So, as I say, this relates directly to polymers, which is in organic chemistry, so paper 2 if you're on AQA, but because it's a bonding type question, don't be surprised to see it turn up on paper 1 as well. So, thank you very much for this one, and I will see you in the next one. For triple chemists, within the organic section here, we're going to look at the new molecules such as alcohols, carboxylic acids, and so on, and a different type of polymerization, that being condensation polymers. But if you're on the additional science, this is largely the point at which you can change module. But for triple chemists, you will need the remaining clips within this series. So, as I say, again, thank you very much, and I'll see you in the next one.